Okay, good morning students. Today we are going to see some more problems in the vector analysis. So already we have studied some basics of vector, how to represent a vector, what are the physical quantities can be said to be a vector, and which are the scalars, and some more details like the addition of vector, then what is a unit vector, what is a distance vector, then what is position vector, and also about the multiplication of vector. So finally we have seen the multiplication of vector both in the dot product as well as the cross product. Hope you have done that problem which I have given in the previous lecture. Now let us see two more problems. So problem number 2, so all of you note down in your notes. So the problem is points P and Q located at 0, 2, 4 and -3, 1, 5. Okay, so this is a 2 points that is represented in the space. It is mentioned in the Cartesian coordinates. Now you have to calculate the following. First, A, the position of vector Rp. Okay, so only the position of vector Rp. Second one, the distance between, so distance between P and Q. And the third one, the distance vector from P to Q. Okay, put vector symbols everywhere. Now let us see the solutions of one by one. So first let us see the position vector Rp. Okay, so the solution. So first case, that is position vector Rp. So already in the previous lecture, I think in the first lecture we have discussed this. So Rp, it is given by Rp vector, it is given by, which means it is from the origin to P, the point P. Okay, so ROP, that is equal to Rp vector minus Ro. Okay, so if you consider that in the 3-dimensional space, so as I said, we have to mention the coordinates in the counterclockwise, x, y, z, and here the point, that is P, and this is O. So ROP is equal to Rp minus Ro, or Rp is equal to Rp minus Ro. So here you know the values. Rp is equal to, so you know the points there. So 0, Ax. So throughout this unit we are mentioning like this. So 0 Ax vector plus 2 AY vector plus 4 AZ vector. Then RO is equal to, you know the origin, it is 0, 0, 0. So 0 AX vector plus 0 AY vector plus 0 AZ vector. Now you have to take the difference between RP and RO. So let me do that in the second page. So now ROP is equal to RP minus RO. So that is equal to, so RP, you know, so totally we can 0 minus 0 into AX vector and 2 minus 0 into AY vector plus 4 minus 0 into AZ vector. So finally we will get, so this is completely becomes 0. So the remaining thing only is 2 into AY vector plus 4 into AZ vector. So this is the position vector with respect to point P. So RP, that is equal to ROP, which is again equal to this value. So this is the answer. So first problem is solved, okay, or the first case is solved. Then 2. The second one, the distance between P and Q. The distance between P and Q. So here, you know, RPQ is the distance vector, okay, between RP and RQ vector. Now RPQ vector, its magnitude is the distance between RP and RQ vector, okay. So before that, I think we have to find the distance vector between P and Q. So first, or here itself I can change. So distance vector between P and Q. So first we finish this, then we can move to the next one. So this is also very simple. You know the value for RPQ. So here I can draw this. So we consider 2 points P and Q. So P and Q. So this is P, this is Q. So this is mentioned as 0, 2, 4, and here it is -3, 1, 5. So the distance vector between P and Q. Okay, right. So here RPQ is given by RQ vector minus RP vector. So what is RQ, RP? So these things you know already. So RQ or RP, which is always called as ROQ and ROP, okay, which is again equal to that ROQ, because origin it is 0, which we can mention like that too. So here we can write ROQ is equal to, so here this we can write -3 AX vector plus, this is 1, so just AY vector plus 5 AZ vector, and ROP. So here we can write RQ is equal to, here RP is equal to, so that is equal to, so 0. Okay, so first 0 AX, so leave that, and 2 into AY vector plus 4 into AZ. So instead of IJK we are using this AX, AY and AZ. So since we have to follow the same notation, in your notes also the same, so we can follow the same here too. Okay, now you just take the difference between ROQ and RP. Next page. So here RPQ vector is equal to RQ minus RP, so minus 3. So first there is no value, so minus 0 into AX vector plus, in the first case it is AY just, so 1, here it is 2, so 1 minus 2 into AY plus is 5 there, minus 4 AZ vector. So you will get minus 3 AX vector plus, 1 minus 2 it is minus 1, so we can write it as minus AY vector plus AZ vector. So 5 minus 4 it is 1, so AZ vector. So the distance vector or PQ vector is equal to this value. Minus 3AX minus AY plus AZ vector. So now we can move on to the second one. So that is the distance between P and Q. So for that, after finding this distance vector, just say, take the modulus of this, then you will get the magnitude of that. So we can find the distance. So here RPQ vector, you know this value, minus 3AX minus A plus AZ vector. So modulus of RPQ is equal to square root of minus 3 square minus 1 square okay, so minus 3 square plus minus 1 square plus 1 square. So you will get minus 3 square, that is square root of 9 plus 1 plus 1. So that is equal to square root of 11, which is equal to 3.316. So that is the value of the distance between. So here you have to note that the distance and distance vector both are different. Okay, so first after finding the distance vector only you can find the distance. Okay, so if someone asks to find the distance between the 2 points, first you find the distance vector, then you can find the distance between the 2 points. Okay, clear? Right, now let us move on to the next problem. So it is another one interesting problem. So first the given vectors A vector is equal to 3ax plus 4ay plus az, and B vector is equal to 2ay minus 5az. Okay, that's all. So now find the angle between these two. Find the angle between A and B. A and B. So the solution. So in order to find this angle between these two, whether you can use this dot product or cross product. Okay. So first let us see, by both method we can find this. So dot product, by dot product how can we find? So A vector dot B vector is equal to modulus A modulus B cos theta. That means theta AB. Okay. So finally what we want to find is the angle. So theta is equal to A dot B vector divided by modulus of A modulus B, that value. So cos theta is equal to, so theta is equal to cos inverse of that value, right? So first let us find the A dot B value, then we have to find A modulus A and modulus B. Afterwards we can find the remaining. Now A dot B, A dot B. A vector dot B vector is equal to, so taking the dot product of this, right? Now what did you do? First multiply this 3 with this 2. Okay. So first let me write that 3ax vector plus 4ay vector plus az vector dot 2ay vector minus 5az vector. Now take the dot product. So 3 into, so here no x component, so we can use that too. So here we just write 0ax vector plus. Okay, so here, so 3 dot 0 ax dot ax plus 4 dot 2 into ay dot ay. So y I have not mentioned the remaining terms, that means 3 into is 2, okay, because ax into ay, that value gives the value of 0, okay, so no need of that. Only this ax into ax, ay into ay, which gives the value of 1, so that's why I have mentioned here. So the remaining terms will become 0. So only I am writing which will gives the value of 1. Then for a z also, so here also for 4 into these 2, this ay and ay, so I haven't considered this 4 into 0 and also 4 into 5, because that value becomes 0. So only the one value I have taken. So here a is set. So here what is the a set? So 1 into minus 5. Okay, so 1 dot minus 5 ay, sorry, a is set, AZ dot AZ. Now, so you will get the value like this. So this is 0, this is 1 AX plus 8 into 1 minus 5 into 1. So you will get 0, this is dot, okay. The positive term it becomes 0, then 8 minus 5. So 8 minus 5, what's the value? 3. So A dot B is equal to 3. Then what we have to find? Modulus A and modulus B. So modulus A. So you know to find the modulus of this square root of what is A? 3 square plus 4 square plus 1 square. So you will get root of 3 square 9 plus 16 plus 1. So 17 plus 9 square root of 26. Okay. Then again we have to find modulus of B. So that is equal to, so in B only 2 terms are there, so square root of that means x term is 0. So here 2 square minus 5 square, 2 square plus minus 5 square, that's meaning. So square root of 2 square, what's the value? 4 plus 25, so square root of 29. Now let's come to the climax. So A dot B is equal to modulus of A vector, modulus of B vector, cos theta AB. So that these things you know. So cos theta AB is equal to A vector dot B vector divided by modulus A vector modulus B vector. So we know the value for this, that is equal to A dot B, that is 3 divided by square root of 26 into square root of 29. So after substituting this value you will get cos theta AB is equal to 0.109. So this you can solve that. Now theta A B is equal to cos inverse of 0.109. The value is 83.727 degree. So this is theta A. Okay. Now cross product, you submit it as an assignment, cross product. So find the angle using the cross product also, you will get the same value. So there for cross product you have to use this. This is equal to AX. First you write the unit vectors AX, AY, AZ. Then write down the components X, AY, AZ. Then B, BX, BY, BZ. Okay, fine. Now, so here you have to write AY, BZ. Then AX, instead of AX you put these values 3, 4, 1 and 0 to minus 5. So I told you already how to do this. So AX into this value minus this value, AY into, okay, so just leave these values along this vertical and horizontal direction. You just cross multiply and take the difference between them. So that's the value you will get finally. So A cross B you will get the value. Then you have to find the modulus of A cross B. Okay. So here the formula is modulus of A cross B is equal to modulus A vector modulus B vector cos theta AB. So here first you have to find the modulus of A cross B. Sorry, this is A cross B just. Then after getting the value, you have to find the modulus of A cross B. At the lastல வந்து ஒரு வேல்யூ கிடைக்கும். அந்த வேல்யூ வந்து square root of, you have to square that, you will get some value. Then modulus of AB, which is same as the what you have find here. Now இதில் இருந்து நமக்கு என்ன அப்படின்னா sorry, this is not cos, sin theta AB. So இதில் இருந்து sin theta AB is equal to modulus A cross B divided by the value modulus A by modulus B. Okay, so first you find the modulus of A cross B. After finding A cross B, modulus of A cross B, then A, B, modulus A and modulus B already you know the value. Then sin theta AB will get some square root of value here also square root of 26 and square root of 29, and by solving this you can find the theta value. So theta AB is equal to sin inverse of the right hand side value. So find the answer. So that will be similar to this 83. Okay students, these problems is enough I think today. Next class we can study the different kinds of coordinates. Okay, thank you.